This is Mastering Mathematics with your teacher, Karen Weston.
Hope you had a good night and that you were able to go to the textbook yourself or examination past papers and you did work some of those simultaneous equations. Now, I also wanted to make certain that I show you a pitfall that some of my students got into. So for example, if I gave you an equation 2x plus 3y minus 10 is equal to 0 and 5x plus 4y is minus 6 is equal to 0, and it says solve for x and y. Look at it. 2x plus 3y minus 10 is equal to 0. 5x plus 4y minus 6 is equal to 0. Not because you're in the examination room. Look and see what it is. Does it look like anything you would have done in your life? And if not, let me start teaching you now that sometimes for the examination, the simultaneous equation comes in this form. Okay? So you translate it and transform it to what you are accustomed to. So you should be changing it to 2x plus 3y is equal to 10. Take the 10 over to the other side. That is what you're accustomed to. Then it is 5x plus 4y is equal to 6. So please get accustomed to a different form where you can get the numbers all put on one side, but just transform it to what you're accustomed to. Okay? By now, I know you would have known how to work that simultaneous equation. So we're going to pass that one and we're going to go on to another type that will be on the, or could be on the examination paper. Now, here it is. Listen to what or how the question can appear on that paper. A stadium has two sections, A and B. Tickets for section A cost A, little case A, dollars each. Tickets for section B cost little b dollars each. Johanna paid $105 for 5 section A tickets and 3 section B tickets. Raina paid $63 for 4 section A tickets and 1 section B ticket. The question in terms of mathematics would say, write 2 equations in lowercase a and b to represent the information above. So let us start and see what we have and guide you through how you would approach that question. Okay, so what do we have? That is why we're saying comprehension and reading, it's important. There is no one subject existing without the other. Okay, they are all integrated. So we have a stadium has 2 sections, A and B. Tickets for section A. Section A would be in little a dollars. Section B would be in little b dollars. Now, so our people, Johanna paid $105 for 5 Section A tickets. So that means she paid 5A plus, and what is it now? 3 Section B tickets would be 3B. And how much did we say they cost? A total of 105. We're just leaving off the dollar signs. All right? So we don't want to make them look too complicated here. So that's what it is. A plus 3B with 5A plus 3B would be equal to 105. When Raina paid for the ticket, she had 4 Section A. So it would have been 4A plus 3 plus 1 Section B. So it's just B, and that she had to pay a total of $63. Okay? Does it look familiar? Yes. That is how you are asked on the examination paper to write 2 equations in A and B to represent the information above. So you have done it. This is the first part to the question. Okay, so this is your equation 1, and that is your equation 2. So you await your marks from CXC for having done that. The second part of that question would have asked you to calculate the values of A and B. And as long as we have 2 variables for which we have to work the values, we know right away we're in the realms of simultaneous equation. And all the rules apply like what we're accustomed to. Now, because the coefficients of the B's look so small, we're going to say multiply equation 1 by 1 because the B coefficient is just 1, and equation 2 by 3 because the coefficient in the first line is just 3. So we would just be writing 1 times equation 1, and then so we're just going to get back 1 times anything will give us back, yes, which is equal to 105. Okay, and this is now our new equation 3. And then it is 3 times equation 2. So then we're going to be getting, it is 3 times 4, which would give you 12A, and it is plus 3 times 1B, which is equal to 3 times 63. So we say 3 3s would give me 9, and it is 3 6s, which would give you 18. And that is how you're getting equation 4. Now again, we're smiling because we see 2 coefficients that are identical. And so if we subtract equation 3, so it's equation 3 minus equation 4, we are going to get for our answer. And remember, it's the same thing we said. If we're saying subtracting equation 3 from equation 4, a simple way you can remember that is just to say, change all the signs in the bottom line. Okay, that is what some teachers would just say, but that is what you're doing because you're putting the whole of equation 4 in a bracket with a negative sign outside. So we're changing all the signs in our bottom row. So then this now becomes negative, negative, negative. All right. So if we have negative 12A with a plus 5A, we're saying which number is bigger, and it's the negative number, and by how many it would be 5. Okay, so we're going to get negative 7A. This disappears, okay, and it's now equal to, so it would be a 4, because right away our negative number is the biggest number, so we're actually saying the 9 is up here and 5 from this will give you a 4, and then you're bringing down your 8. Okay, but it is negative. All right. Now again, we say the variable cannot be a negative number, so we're changing the signs immediately, and we're going to get then that it is 7A is equal to 84, We don't want 7a, we want 1a. So it is 7a divided by 7 be equal to 84 divided by 7. Okay, and so we're going to get a then would be equal to 12. Okay, so where we have a in any of our equations, we're going to replace it by the number 12 to find a value for b. So we're going to use equation 2. So using our equation 2, so we say substitute 12 for a in equation 2. And so equation 2, it says 4a plus b is equal to 63. And that would now imply that 4 times 12 plus b would be equal to 63. We know right away that 4 12s would be 48. So it's 48 plus b is equal to 63. And b then would be equal to 63 minus 48. And 8 from 13 would leave me with a 5 and 1 here. So then that then would be b would be equal to 15. So that in terms of buying a section A ticket, you would be taking so a section A ticket would be equal to $12, and for our section B we would be paying $15. So again, that is how we're using, and you can see where simultaneous equation is used in the real world. Okay, so when you buy your carnival tickets and you're buying for your Queen show and you're buying for your Calypso show, you're saying right away how much tickets you had to buy. If you're buying them for the Andy Roberts stand or you're buying them for the Vivi Richards stand, you know you'll be paying different monies for them. So we see right away where simultaneous equation comes up in our real world situation. Now, our little students listening and waiting for their turn to see what it is that Miss Weston is going to tell them today. And all we're going to say is that, again, we want to make certain that we understand that you know your 10 times table. What did we say you had to do when you're multiplying by 10? Am I hearing you giving me the answer? Yes, that is right. Any number multiplied by 10, we're just adding a 0 to that number. And why? Because in terms we have two numbers, and so it's in the ones position, it says make the number 0, and in the tens position, you're writing one group of that number. All right? So we understand what we are doing when we are multiplying by tens. Next time, we're going to see and to ask you further questions if we have our different numbers, what you can do. Now, we're going for a break. We're giving you a chance just to digest everything that we have told you, and we'll be right back.
If you know the answer to a question is incorrect and you cannot find the mistake, start over on a clean piece of paper. Oftentimes when you try to correct a problem, you continually overlook the mistake. Starting over on a clean piece of paper will let you focus on the question, not on trying to find the error. Always read math problems completely before beginning any calculations. If you glance too quick at a problem, you may misunderstand what really needs to be done to solve the problem.
All right. Hope you had a nice break and you're ready for the last part of this section. We have done our simultaneous equation. We're cooling down. There's nothing new for you to know. I'm going to allow the adults to end on a high note in terms of our simultaneous equation. But every time I've been putting my little primary school students as second fiddle citizens. So this time, guess what? For this section, we're going to start with our primary school students first. Now, there's one thing I want to say. Teachers for primary school children, these children cannot learn as fast as adults. It all has to do with brain development. There are certain things where you're thinking that they should know. That part of the brains has not been fully developed, so they don't know. And in any case, once we are teaching mathematics, one concept at a time. Take it easy, make certain that you know they understand that particular concept, and then go on to another one. Do not give them two different concepts at the same time as a homework activity. It is only stressful for the parents and the student. Of course, we have our fast student in the classes and they would be able to conquer. But we have to pay attention to that poor little citizen who does not have anyone in his house who can actually guide him along and has to rely on what he learned in school. Although I think that should now be a thing of the past, because we are saying we're going to be putting people in your communities, giving you the names who will be there to help you do something like that. So no longer do we have to sit and suffer. Giving them a homework. Homework is a reinforcement of one activity, one concept that was done in the classroom. Again, I want to just deal and end with the primary school students looking at this LCM. It is unfortunate, but I was on my sister island Barbuda last week, and there is something that I saw that did not go down too well. We cannot teach students methods for the LCM using multiples. Okay? Using multiplication table is not the best aspect or the best strategy to use in terms of teaching little children how to find the LCM. It's always better to go back to our prime factors and see that we can make them find the LCM in that fashion. Again, I'm going to use this method to show you when we are finding the LCM what we are using in terms of primary school children. My primary school teacher, I think she's still alive, you know, this one teacher Hyacinth, you know her? Yes, she's in Parham, right there at the top by the Roman Catholic Church. It was probably her who taught me the LCM along with Miss Scotland and teacher Muriel and those guys in the primary school, and it still is with me for today. Okay, so once teacher Pepsi would have taught us how to do our counting, our grouping, place value, these guys had this thing of taking up and showing us how to do LCMs, and it is still here for today, and it still works. Okay, we want them to do it in terms of our prime numbers, so they're going to be saying 2 into 4 goes 2 times, leave it like that. 2 into 8 goes 4 times, leave it like that. 2 into 16 goes 8 times. Okay, can we use 2 again? And we say yes, and we're going 2, and so you're going and saying 2 into 2 goes once, into 4 2 times, here 4 times. Can we use 2 again? Yes. Once we have achieved the position of a 1, we bring it down because our goal is to make the last line ones. Okay, so 2 into 2 would give me 1, and 2 into 4 would be 2 times. So again, we can use a 2, and we're just bringing down the numbers that 2 would not go into. So it's 1, it's 1, and it's 1. And then we can say bingo, because that's it. So the LCM then would have been the numbers at the side. It is 2 times 2 times 2 times 2. And it is now equal to 2 2s 4, 4 2s 8, 8 2s 16. So the answer is 16. So for the LCM, let's go right away. Teach them this method for me, please. Look at it where they're going with their numbers. See if the number can get into it. Unfortunately, I used all that. You didn't have to use another number this time. But next week, we're going to pursue this a little more. But it is not the best thing to let them go by multiple. So they're going 4, and then going 8, and then going 12, and then going 16. Because if you have 8, look at how big the number gets. 8. And then after this, you're going 8, and then you're going 16, and then you're going 24. And these children are just what? 7, 8, 9. So we don't want them so high. Look at, if I have a number 16 here, look at what that is going to be. So that is 16, and that is going 32. How many fingers they have to count to go all the way up to say, then they're looking again, because you see them counting their little finger. There's nothing wrong with that. But they can't get that if you're going to ask them to do something like this and going all the way up to 48. Okay? So that is why I don't want this method for them, especially as far as our grade 3. Oh, let's get back to the simple one, because for this one, they're learning to do their prime numbers, and they're learning also that they can see sometimes where they can be saying if numbers are squared or not. One concept at a time. One concept, one method. Okay? For the teacher who is going to be using the tree method, if that is the one you're sticking with, do one method at a time. And please do not teach them LCM and HCF at the same time. It is too heavy a concept for them to understand. So very slowly, LCM, get them into thinking about prime numbers, get them into thinking about the set of numbers. What do we call them? Even numbers, prime numbers, composite numbers, rectangular numbers. Do not forget those, okay? Keep testing them, write them on the fridge, put them on the walls, let them see them around the house, and just keep testing them. Do not wait until the week or 2 months before, especially the grade 6, the grade 2, or the grade 4, or any exams. Just let it be an ordinary conversation every day and start pumping up our students to use mathematics, okay? And finally, for our adults, the last thing that we are going to be doing is a nice, simple, simultaneous equation to send you on your way, because next week we will be looking at something else where I'll be showing you how to multiply quadratic equations, okay? So this is now 3x plus, oh, this is running out too. So it is 3x plus 2y is equal to 13, and it is x minus 2y is equal to -1. And we are asked to solve the simultaneous equation. So as a gift from the gods, I'm giving you, and this is on the exam paper. You can't believe that, okay? A real gift from the gods. What do we have to do here? We can see plus, and we see the we see coefficients that are the same. So we can just be saying immediately, equation 1 plus equation 2. Okay, and what are we going to get here? We're going to get 4x, the y's disappear, is equal to 12. And so we're going to get right away that 4x divided by 4 would be equal to 12 divided by 4. And so x then is equal to 3. Okay? So now we are so good, we're leaving out some of the little in-between steps, because that's where we want to get. And we are going now and saying substitute. So we're going to say substitute 3, 4x in equation 2. We're going to use equation 2. So that is x minus 2y is equal to 1, to -1. So where we have And this would imply that 3 minus 2y would be equal to negative 1. And we can get negative 2y would be equal to, take the 3 over to the other side. Negative 1 is not moving. This comes over as negative 3. So it is negative 2y is equal to, and I have my students with problems like this. But this is saying we have one group of persons here. We have 3 here. So how many do we have in all? It's negative 4. This is not saying multiply by, okay? In multiplying by, we would have been getting the negative signs coming together as if it is a hopscotch that we are jumping. Here, it's a number and then another number. So we are adding them. How many do we have, okay? So then changing the sign is 2y is equal to 4, and 2y over 2 would be equal to 4 upon 2. So y would be equal to 2. Okay, so our solutions would then be saying that x is equal to 3 and y is equal to 2. Okay, there's one of my secondary schools that I'll have to visit to see exactly why one of my teachers is saying to my students, no, they don't have to write all this. Yes, I've been around the table with CXC, and yes, you have to write all this. Okay, do not try shortcuts. Do not think you can do half, because if you don't show all the steps in your work, you will not be given the marks. The answer is not what CXC wants to see. The development in terms of logic and reasoning is what is important. And there are specific and particular ways in which certain sums has to be worked, and it must be done. There's no shortcut. All right? Now, so we have done our simultaneous equation. My primary students have done their 10 times table. We have introduced a method to say to use your LCM. We have given you information to say you can email us at mastermathebu@gmail.com, and you can go to youtube.com/mastering mathematics to get more of this, so that if you missed it on ABS television, you can go there in your own time and see the same lesson. And again, we are now formulating our website, http www.masteringmathematics.info, where we will be putting up some assignments for you with the solutions. So until next time, and as we thank all the people working behind the camera and making this a real pleasure for us to bring this into your homes and making mathematics a doorstep experience, Karen Weston saying, see you next time.
Join us next time for another in the series, Mastering Mathematics, a production of the Education Broadcasting Unit in the Ministry of Education and ABS TV.